Okay, Assalamualaikum and selamat sejahtera. My name is Siti SYAHIDAH binti ZIKRI. My matric number is 01DTT22F1003. So today, me and my friend will be presenting on the mini project 2. So I will be presenting on the question 1. So for question 1, write a simple C++ program that insert a list of data into stack as shown in following figure. At the end of the program, show the pop operation to remove all elements for the stack. So that is the figure. Let's move on. Coding. Okay, so this is the coding. So the size of the stack is actually 3, but it will display as 2. So the minimum top is -1. So if it's empty, the top will be -1. So if it's full, the top will be 2. Okay, so then we got the coding for to push any item like the character P, U, and O. Then we got the below the coding of character pop. Okay, next. Okay, so for line number 35 until 39, it is to check the stack. So for line number 47 until 50, it is to display the element in the stack. So for the line of 56 until 72, so the line for 56 until 58 is to create a new stack with a fixed size of 3. So as you can see, 61 until 63, it is pushing the element of P, U, and O. So for the line of number 66 until 67, it is to display the element in the stack before popping, which is P, U, and O. Okay, for the line number 69 until 71, it will display the top element of the stack, which is O, and the top stack will be 2, as the minimum number is -1. So for the line 74 until 75, it is to pop an element from the stack. So the pop element will be O. Okay, for the line number 78 until 81, it will show you the element after popping, the top element of the stack, which is U, and the top stack, which is 1. Okay, that's all for me. So now for the output. Okay, so this is the output. So before popping, the element in the stack is P, U, and O, and the top element of the stack is O, the top stack is 2. Okay, afterward, the popper element is O. And finally, after popping, the element that left in the stack is U. The top element of the stack will be U. Finally, the top stack is 1. That's all for me. Now, I will give it to my friend BAIRAVEE to present question number 2.
Good day everyone, my name is BAIRAVEE MUNUSAMY and my matric number is 01DDT22F1060. Thank you SYAHIDAH. Today I'll be continuing our presentation for question number 2. Write a simple C++ program that can insert a list of data into queue as shown in following figures. At the end of the program, show the dequeue operations to remove all the elements from the queue. So first, I create the struct, which is struct queue with the members of front, rear, and queue. Then I push all the elements into queue. The elements are P, U, O. Then the code will display the initial queue, which is consists of P, U, O. Then to remove all the elements from the queue, which is dequeue, I use while loop. And then to display the and then after that I display the final queue. And lastly, utility function to display the queue, I use while loop. The output for this coding is initial queue, P, U, O. Final queue, nothing. That's all from me. Next, I will pass the presentation to INSIYA.
Assalamualaikum and salam sejahtera to anyone who's watching. My name is INSIYA binti JUZAR. My matrix number is 01DDT22F1088. Now for question 3, write a C++ program to show implementation of binary search tree using linked list. Your program must include all the operation in binary search tree, including creating BST, inserting item into BST, count item in BST, deleting item from BST, and traversal of BST. Now we will be looking at the answers for the question 3. Now first of all, we will be creating a structure for the node, where integer data, node left and node right is the members of the structure. Then we'll be creating a BST, where we will set the BST to null. That is why left and right will be null. And then we'll be inserting BST, where if root equals to null, it will return back to the creating BST function. And then if value is less than root, that means the number is less than the root, we will go to the left side. And if the number is higher than root and is greater than root, it will go to the right side. Moving on, we'll be seeing the code for the function to create minimum value node. After that, you can see the deleting BST code. So if root equals to null, it will return to root. If value is less than root, it will go to the left side of the BST. And else if value is greater than root, then it will go to the right side of the BST. And then we have else, and then we have if the left side equals to null, and else if right equals to null, it will delete the root. And As you can see below here, we have the code for minimum value. And now we'll be seeing the traversal for BST. So now as you can see, we have the function for void pre-order, in order, and post order. Now one thing to keep in mind is where you put your C out. So C out for pre-order will be before left and right. And then for in order, you will be in the middle of left and right. And for void post order, C out will be after the post order traversal for left and right. And then below you will see the count node function, where you will count how many nodes you have. And now we'll be seeing our main function, where we will insert 10 to 80, numbers 10 to 80 in a non-sequential order. And then we will print and see out our pre-order, in-order, and post-order traversal. Moving on, we will count, meaning we will see how many numbers of nodes that we have using the count node function. After that, we will do the deletion by creating a new variable, which is integer del, and it will compare del equals to 10 or 20 until all the way to 18. Now, if one of those numbers that we input is in this if bracket comparison, and it will delete the number from there. Now, lastly, we'll be seeing the output after we have deleted the number. So here we will see the pre-order, in-order, and post-order after the deletion. So now as you can see for the output, we have number 10 to 80, and we have number, and you can see the pre-order, in-order, and post-order. Now we have number of nodes also, which equals to 8, and we will enter the number that we want to delete. Here I have put an example of number 40, and as you can see, it will show the pre-order, in-order, and post-order after 40 is deleted. Now that is all from us. Thank you so much for watching.